My name is Glen Jackson. I'm a professor of chemistry and biochemistry at Ohio University, and I'm also the director of the forensic chemistry program. Forensic chemists will work in many types of labs associated with law enforcement, and that could be a coroner's office, or a toxicology lab, or a forensic lab. Chemists on the chemistry side, they would be analyzing drugs of abuse or trace materials, arson and explosives. I find it fascinating, and I love the idea that what we do is extremely practical and can actually, has a huge impact on someone's life, and hopefully in a positive way in terms of victims. I knew at about 10 that I was going to be a scientist, and about 14 that I wanted to be in chemistry, pretty much, or biochemistry maybe. And then at 16 or 18 that I really wanted to stay in academia and do research and help contribute to the knowledge in society, to help develop new ideas or invent new things. I didn't know what, but that someone would pay you to do that for a living, I thought was brilliant. Getting into chemistry was because I love the natural sciences and I love trying to understand the world around me. I loved analytical chemistry because I love the instruments, I love the very expensive toys that we get to play with, and the types of measurements that we can make. I think it's amazing. For working in a crime lab, the minimum requirement is a Bachelor of Science or a Bachelor of Arts degree, and usually in the natural sciences. Most crime labs prefer to see students with degrees in chemistry or biology, depending on their application, depending on whether they're a forensic chemist or a DNA scientist, for example. Main advice would be to make sure that you enjoy it, because if you don't enjoy it, your life's going to be miserable. So you have to have a natural affinity for it. And being able to quantify things and do some quite rigorous math will really help you understand the chemistry and the physics behind the measurements that we make. There's at least two reasons why I find this job so exciting. The first is when we do research and we discover either new methods or new techniques or new ways of making measurements that other people could use. I find that very exciting. The other aspect is actually being able to examine forensic evidence and draw some conclusions based on the evidence. There was a case that we worked on a few years ago that involved suspected trace human remains. So there was a stain on the concrete floor, and there was a question as to the validity or the origin of the stain and whether or not it was in fact human. It was actually fatty acids which are formed from bacterial degradation of human remains. Although the residues were consistent with human remains, the stunning visual appearance of the stain, the very vivid white kind of ghostly outline of a human figure, was almost certainly caused by acidic staining that was deliberately put down in the shape of a human body. But being able to use chemical measurements to understand, or bust or make an urban myth like that was pretty cool. When I meet with prospective students and their mom and dad are sitting here, and the mom and dad say, okay, well if they can't get a job as a forensic chemist, what else can they do with this degree? The students are trained to be analytical chemists. They can analyze any substance in almost any matrix. Almost any sector of the industry or the economy is supported in some way by analytical chemists, whether it's the petroleum industry, which is pretty much always booming, whether it's drugs or paints or polymers, Silicon Valley, which also needs analytical chemists to assess the purity of the minerals and chips. So pretty much any sector is booming at any one time. It really helps to have a strong basis in math. That turns out to be the best correlation that we have, the best measure we have in determining success in our program, is how good students are in math. Focusing on the math and the natural sciences and making sure you understand the type of logic and the reasoning and the thought process that scientists use when they try and understand the world around them. In terms of bachelor's degrees, there's lots and lots of choice. There's a lot of forensic science programs, and they vary in their vigor. More labs are requesting that students have master's degrees, and this is to deepen their understanding and to develop their skills and analytical skills and communication skills in terms of testifying as well, and just understanding the context of forensic analyses a lot better. seeing the results of your science and what it can do, whether we end up on TV or whether we can help solve a crime or help understand, give peace to a victim or something like that. That's still very, very rewarding on a deeper level. One of the kind of downsides to working in the forensic sciences, which is when you don't have an answer. There's just not enough information in the evidence to come up with a black and white conclusion about it. And this is often the case in the sciences, which is where we make measurements and we can form a hypothesis that's consistent with what we have, but we can't know it for sure. But really there's not much to complain about. We have so much flexibility in our jobs here, and we get to help society, and we get paid for it quite well. So there's not really much to complain about.